So a jail has a certain number of prisoners and a number of treats to pass out to them. I hope everybody can see my screen. Yeah, I think everybody can. Anyway, so a jail has a number of prisoners and a number of treats to pass out to them. Their jailer decides that the fairest way to divide the treats is to seat the prisoners around a circular table in sequentially numbered chairs. A chair number will be drawn from the hat. Beginning with the prisoner in that chair, one candy will be handed to each prisoner sequentially around the table until all have been distributed. The jailer is playing a little joke though. The last piece of candy looks like all the others, but it tastes awful. It tastes very bad. Determine the chair number occupied by the prisoner who will receive that candy, who's going to receive the last candy, right? So basically, if I understand it correctly, a chair number will be drawn from a hat. Beginning from that prisoner in that chair, one candy will be handed to each prisoner sequentially around the table until all have been distributed. So we are not starting right at, like, imagine an array. So we are not starting right at 0 point. Rather, we are starting at a midpoint, not a midpoint, somewhere within the array. And from there, we'll keep giving until we reach the end. And it's a circular table, so we might go at the start also. And at that point, when we end, that last person is going to receive the awful candy. It could also happen. It could also happen that you go through a circle. So I'll repeat this, don't worry. A prisoner can receive any number of treats based on the order of distribution of treats. Okay. So let's look at example. First line contains T, denoting the number of test cases. The next T lines each contain 3 space-separated integers. N, the number of prisoners. M, the number of sweets. S, the chair number to start passing out the treats at. And where does S start from? Do they have given answer for that? So for example, there are 5 in this case. Let me also just open it up on slides over here. So this is a jail treat. Yeah. Somebody saying I didn't get this question. Yes, the questions are randomly given, by the way. All the questions were randomly given. That is, there was randomization. Even if you didn't get this question, don't worry. It's still useful to you because this could come in the TCS Digital. It's a previously asked TCS Digital question, everybody. All right. So this is the input. Let's start with this input first. 2 is the number of test cases. So I'll start with the first test case. Yeah. What this means is there are 5 prisoners. 5 prisoners. There are 2 chocolates. And we start distributing. First, chair number 1 gets first chocolate. How can I say chair number 1? That's the one over here. Okay. What is the question saying? The question is saying something like this: A, B, C, D, E. Let's say there are 5 prisoners overall. Let's say, so this is 5 prisoners. Okay. And there are 2 chocolates. And I'm starting at chair number 1. Means that there are 5 prisoners. If I start at chair number 1, let's say A is chair number 1. Okay. Assuming that it's doing a 1-based indexing, like the numbering starts from 1, 2, 3, 4, 5. Let's say it's something like this. Okay. So chair number 1 gets a chocolate. Chair number 2 gets a chocolate. Who is the person who is not going to get or who is the person who gets the last chocolate? Everybody. Who is the person who gets the last chocolate? B. How many chairs? 5 chairs, because 5 prisoners, so 5 chairs. You can also say prisoners / chairs. Okay. B is the last person to get a chocolate. And what they're saying is the jail master is a little bit cruel. The last person to get the chocolate actually gets a bad chocolate. Okay. Which is the bad chocolate, everybody? Which chocolate don't you guys like? Or rather, which is a good chocolate as per your? Let's have a little fun also. What's your favorite chocolate? Yeah. But anyway, this person does not get that chocolate, whichever is your favorite. Let's say Cadbury is your favorite. Yeah, dairy milk, somebody is saying. So let's say dairy milk is your favorite. This person doesn't get. They probably get some Karela flavor chocolate or something. Okay. They don't like the chocolate. It's a bad bitter flavor chocolate. They don't like it. So they get this. Okay. So you just have to basically tell who is the last person to get the chocolate. That's it. Who is the last person, the last index to get the chocolate. Okay. So in this case, the first answer is 2 because you have 2 chocolates, right? And starting from chair number 1. So that means that the second person gets a bad chocolate. If we go to the next test case and do something like this, which is 5 to 2, this means that A, B, C, D, E, 5 prisoners. That's 5. 2 is the number of chocolates. So you have 2 chocolates. And this time we are starting from number 2, which is B. From B. So now 2 chocolates will be given out. So B gets a chocolate and C gets a chocolate. Who is the last person to get a chocolate? C is, and which is chair number 3 gets last chocolate. Okay. Chair number 3 gets the last chocolate over here. Clear, everybody? This part? That's why the output is 3. Okay. Now, did you guys get the question? Those of you who are saying get the question. Did you all get the question? Okay. Awesome. Good to know. So what's the proper logic for this one? Always start with the simplest brute force approach. Brute force means the simplest approach out there. Okay. Another test case. Sure. Let's take another test case. Okay. Let's take another one. Let's say there are 8. You are very good, right, to point out that we should always take another test case because we never know what kind of edge cases we can. Let's say there are 8 chairs and assume that 6 chocolates are to be given out and that we are starting at chair number 3. 6 chocolate to be given out and starting at chair number 3. So it's something like A, B, C, D, E, F, G, H. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 chocolates are there. 8 chairs are there. And I'm starting at chair number 3. So if I start at chair number 3 over here, which chair will I end at? 1, 2, 3, 4, 5, 6. Right? So I'm ending exactly at chair number 8. So the answer here will be 8. This is the last person to get. Okay, everybody, is this one clear? Now I'll take another test case, but is this part clear, everybody? Okay. Now tell me who will get the last chocolate if there are, let's say, 20 chocolates to be given. Everybody can get more than 1 chocolate also, no issues. So if there are 20 chocolates to be given, who is the last person to get? What do you guys think? Okay, very nice. Did you actually count and do it, or did you try to do it using some formula? Did you all count and do it? Did you all count 1, 2, 3, 4, 5, or did you use some other trick? So many of you are saying 6 or F. Did you count it or what? You actually counted it. So C is 1, D is 2, E is 3, F is 4. Did you do that, or did you use some trick to actually do it? Yes, I don't know if 6 is the right answer, but I'll just check it out. Okay, somewhere is saying modulo. Interesting. See, we have 20 chocolates, right? So we have 20 chocolates to give out, meaning that I know that from 3 to 2, how many elements will be there? There'll be 8 elements, right? This is 6 elements. So to do one circle, that means I'll again be back at 3 after distributing 8 chocolates, right? After 8 chocolates, I'll be here. After another 8 chocolates, I'll again be here, right? Meaning how many? I've distributed 16 chocolates so far, right? After delivering 8 chocolates, I'm here. After another 8 chocolates, I'm here. 16 chocolates have been delivered. Means I need to deliver 4 more, right, everybody? Did I make any mistake here? All correct, because I'm starting at 3. So let me again try 1, 2, 3, 4, 5, 6, 7, 8. 9th chocolate starts from here. 9, 10, 11, 12, 13, 14, 15, 16. I'm here. So up until now, I've delivered 16 chocolates. Starting from 3, I will deliver 17, 18, 19, 20. So my 20th chocolate will be delivered at 6. So the answer is 6. So I actually counted it, but just wanted to tell you how you can figure out how many chocolates will be delivered before we have to do the final stretch. You can actually count and do it. Does this make sense, everyone? So can anybody give me a quick logic on this one? Let's say I'm your interviewer and your interviewer asks you, oh, hey, great, you solved the jail trade question. Awesome. Okay, you solved the jail trade question. Super. can you tell me what's the logic of solving this? Given that this is, I'll also give you, this is n number of chairs, m number of chocolates, s starting point of that. Given n, m, and s, can you tell me what is the logic of solving this question? Okay, try to write it in 1 or 2 lines. Put it on the chat. Try to write it on 1 or 2 lines. And if an interviewer asks you, you solved it, great. So can you tell me how you solved it in the exam? For those of you who are writing 3 plus 20 modulo 8 minus 1, that is okay for this one. But what happens in the case where it's n, m, and s? Does it work in all cases? 3 plus 20 modulo 8 minus 1, does that work in all cases? So we should run for loop and decrease chocolate count. Okay, that's also one approach. So I'll put both approaches here as well. Okay. Can you please explain again? Sure. Which part did you not understand? Which part did you not understand? Okay, let me write the approach here. So somebody is saying run for loop and keep decrementing the chocolates, right? If you reach end, go back to start. Right? If you reach the end, you go back to the start. Right? This example you want me to explain again? Sure. So let's say I start at number 1 here. What is going to happen? From 3 up until 2, because it's a circular table, from 3 up until 2, I have done how many? I've done 8 chocolates. How? Because that's how many numbers are there, right? That's how many chairs are there in this. So 3 up until 2, 8 chocolates are done. When I'm back at 3, I'm on my 9th chocolate. From 9 up until 16, I have done my second round of 8 chocolates. So now that I'm at C, I'm on my 17th chocolate. Did you understand this? From 3 to 2, 8 chocolates are given. So 2 rounds of 8 chocolates means 16 chocolates delivered. Now I'm on my 17th chocolate here. 17, 18, 19, 20. At 6 is where I have my last chocolate, the awful chocolate. Okay. You got it? So this is, yeah. So somebody is given this approach, by the way. Let's first look at this approach. This is the simplest approach that you can do. You keep running the loop, right? You keep going round and round the array and, hope you get the answer. But let's go back and see why this does not work. Is if you look at the constraints. So this is another thing that the constraints will always give you. N and M can be 10 raised to 9, meaning that 10 raised to 9 is huge. Generally speaking, 10 raised to 6, everybody note this down. 10 raised to 6 is the maximum number, or 2 into 10 raised to 6, 3 into 10 raised to 6, but order of 10 raised to 6, maybe 10 raised to 7 sometimes, but usually 10 raised to 6 is the maximum number of iterations you can ever do in your test or in your code. If you're doing 10 raised to 9 iteration, meaning we are saying there are n chocolates. There are 10 raised to 9 means 1 trillion, this becomes 1,000 million is a trillion. So this big, am I correct? Trillion is 10 raised to 9. Billion is what? 100. No, sorry, this becomes a billion. My bad. Sorry. This is billion. So this is 10 raised to 9 is a billion. In a billion, if you try to do billion times, it's not going to go. That many for loops, it cannot do. You can do at max up to a million. You can't do more than that. Okay. It goes only till a million. You can't do more than that. So if there are a billion chairs kept there, there are actually a billion chairs kept. You keep doing for loop, you're going to get time limit exceeded. All right. You need to come up with a better solution than that. The better solution is exactly what we were looking at. So this is the brute force. You will get some test cases passed, but otherwise you'll get a time limit exceeded. So this is brute force. Optimized approach is exactly this. First try to count how many rounds will be done even before you start, right? Meaning that you'll again be back at the point C. So how many rounds will be done before that? That's going to be M modulo N, right? These many rounds will be done anyways before you are done. These many chocolates, M divided by N, this is how many rounds will be done, right? So in our case, 20 divided by 8 will give you 2, integer division. 2 rounds are already done. Okay, how many chocolates are left? Chocolates left. How many are left? There are M modulo N chocolates left. M modulo N chocolates will be left over here. Okay. So let's say there is 1 chocolate left. You are at index 3. There's 1 chocolate left. Okay. What is the index 3? That's the starting point. So if there's one chocolate left at the starting point, then what do? Where will it go? Let's say you're at starting point. One chocolate left. You're at the starting point S, and now you have one chocolate left to deliver. Who will get this? Who's going to get this chocolate? Not D. Let's say there were 17 chocolates to give. 2 rounds went in giving everybody. Okay. 2 rounds went in giving everybody. So 1 to 8 happened here. Another 1 to 8 happened here. 2 rounds went. One chocolate is left. C is the one who's going to get it. S is the one who's going to get it. Because you're at the starting point again, if you have just one chocolate, S will get it. If you have 2 chocolates, S plus 1 will get it. S1 will get 1 and the next one will get 1. Meaning that S plus remaining chocolates minus 1 will give you last element, right? The person who gets the bad chocolate, the awful chocolate. Okay. What is the remaining chocolates? As we saw, the remaining chocolates are nothing but M modulo N. M modulo N. Okay. This is the formula. If you got this formula, this was the answer. That's it. No for loop, no while loop. Take input the integers and run the formula. That's all you need to do. That's it. Okay. Once again, explain this formula. Sure thing. I am starting at 3. I am starting at this 3. Okay. This is my S point. This is given my S point. Now what I do is I start distributing the chocolates. How many rounds will I complete? Let's say there are M chocolates to give. How many rounds will I complete first? The person asked me to explain again. How many rounds will I complete before coming back to this S? Very good. M divided by N. I'm going to complete N divided by M divided by N. Let's say there are 20 chocolates. I'm going to complete 2 rounds. And I'll again be back at the starting point. At the starting point, I now have to deliver the remainder of the chocolates. Correct? Starting from the starting point. So if I have to deliver the remainder of the chocolates, how many chocolates do I have to give now at the end? What is the remainder of the chocolates now? That's going to be very good. Yeah. M modulo N remaining chocolates. M modulo N remaining chocolates. Means that if there is 1 remaining chocolate, I want to give to S. 2 remaining chocolates means that I want to give to S plus 1. Means that if there are S plus M modulo N minus 1, means that how many remaining chocolates were there? Subtract that with 1 plus S. So there's 1 remaining chocolate, 1 minus 1, 0, it goes to S. There's 2 remaining chocolates, 2 minus 1, 1 goes to S plus 1. Does that make sense now? Did you understand that? Person who asked me to repeat. Okay, super. So let's quickly write this. I'll write it in Python, but the pseudocode is the same for everybody. Just take Python as a pseudocode here. First things first is input the test cases is equal to input for cases in range TC is the test cases. For each input, you're going to take S, M, and N, right? So just a quick, N, comma M, S, comma S is equal to list map int input dot split. You can do it like this for those of you who are very fast with Python. Another way of looking at it is, let's say ARR is equal to list map int input dot split, right? And here ARR 0 is going to be, or rather N is going to be ARR 0, M is going to be ARR 1, and S is going to be ARR 2. Okay. Then what we'll do is we'll just try to find out answer is equal to, it is S plus N modulo M minus 1. Right? This is what the answer is going to be. We have missed out one edge case though. We have actually missed out one edge case over here. Can anybody tell me one edge case? As I'm writing this, I'm trying to figure out, right? Yeah, very good. Imagine, no, wait. Correct. Yeah. So let's take out one more edge case here. Let's say your starting point was 7. Let's say your starting point was 7. If I apply this formula to it, so the starting point is no longer 3. It's no longer 3, but the starting point is actually 7 over here. If even one round is not completed, then m modulo n will be m only, right? That's the beauty. 4 modulo 8 will be 4 only. Hope you got that. Okay. Anyway, so the edge case is this. If let's say this is the S, everything else remains the same. So S plus, what is m modulo n? M modulo n is 4 minus 1. What does that look like? S is 7 plus 4 modulo minus 1. It is 10. Do we have an index 10 in this? Do we actually have an index 10 in this at all? No, right? So where should it go? It should have gone to 2. It should have gone to 2, right? So we can just do a modulo n again. That's modulo 8, right? So you have to do again a modulo to get the correct answer. Okay. So again, so we just have to add finally another modulo n as well. In the case that even that is overflowing, we need to come back. So print answer. Let's see, this one should work out. Let's see if it works out or not. Okay, it didn't. We are giving 1 and 2. Hold on. S plus n modulo n minus 1 n modulo n. I guess plus 1, right? Because we could 1. So I'm asking why. Yeah, sorry, correct. M modulo, not n modulo. M modulo. Thank you for that. Yeah. That works. Okay. We are getting wrong answer in 2 cases, right? We are getting wrong answer in 2 cases. What could those 2 cases be? Yeah. I think I know the 2 cases. Right. There is again edge cases, so we'll have to again think of it. Let's say I give you yeah, 1 second. If answer equal to 0, then answer is equal to n, I believe, right? Because yeah, now it works. So the only thing in modulo is, if let's say you're at position 8, right? Minus 1 should not be there for less than 8. No, it's completely fine actually. There's no issue with the minus 1 part. The issue is, why would you say it should not be there for the less than 8? So okay, some of you are saying that if I just take my formula again, if I just take this formula, let's say, right, let's take this formula here. Some of you are saying for less than 8, it should not be there. In the case that let's say m is I don't know, let's say m is just, let's say s is 2 and m is 1, right? So what would it be in that case? S plus 1 modulo 8 will be 1 only, minus 1 modulo n. So it's correct only, right? It should be an S, because 1 means 1 chocolate. So the starting person is the one who gets it. So minus 1 is 100% needed. Why you need minus 1 is actually because we are doing 1 based indexing. That's the reason you actually need minus 1. For 0 based indexing, you would not face this issue mostly. No, even in that case, you would face. The reason you're actually facing is because at the starting point, 1 starts. At the starting point is the one who gets the first chocolate. So it's not about 0 based or 1 based. It's the starting person gets that 1 chocolate. That's the issue, right? So that's a minus 1 is absolutely needed. Now, why did I do that modulo if it's equal to 0? In the case, let's say that you get 8 at the end. Let's say that, for example, let's say S is 7. So I'm starting at 7 over here. And I have 2 chocolates to give. So again, let's take that formula. What's in the formula? Let's just put it here. 7 plus 2 modulo 8 is 2 only, minus 1. What will this be? This will be modulo 8. 8 modulo 8 is equal to what? Is equal to 0. But we don't want 0. We want it to be at the 8th position, right? So that's why I said that if answer is 0, it means that is actually at the nth position, because it took modulo with itself. It's at the nth position, and then we printed that answer. All right, clear everybody, this part? Did you understand the last edge case, why we needed it? Sir, can you explain how to take inputs in Java? This same input? Yeah, sure. Once explain that m modulo n plus s minus 1. So because in the interest of time, I'll have to go on to the next one. Plus, just to check the recording once, pause the video at this point and try to understand that once yourself as well. I repeated it twice already. So just in the interest of time, I would say this, or at the end of the session, once I'm done with the next question, let me do that, because otherwise, we'll be stuck on this question. So sorry for that, but just give me, let's just stay back at the end of the session. I'll explain it to you. Okay. Is this the easy or hard from the 2 coding questions? This is the easy one. This is the easy one. Okay. This is the easy one. And honestly, everybody, if you know your maths, then this is the easy one, right? Like this is simple, right? You want to do it in Java? Again, everybody, like this is fairly straightforward in Java, but cool, we'll still do it. The only thing you need to remember with the Java part is public class main public static. The only thing you need to remember is that you need to take a long in this one, because the number can be very large. Sir, where can we practice this question on the platform? It's available on the platform. Reach out to team@edyst.com. They'll show you. Okay, so we need to have a scanner as well. So import java star, let's say, and scanner scan is equal to new scanner system.in. Then what else was there? First take test cases. So int is equal to scan.nextInt. All right. Then what do we do after that? We take the array. So we go for int I equal to 1, I less than equal to test cases, I plus plus, and for we'll do int n is equal to scan.nextInt, because in Java you don't really care about the next line and so on, right? Which is the case with Python. Java you can do this, and it's not next int actually, it's going to be next long n, because they are big numbers. Long m, long s is equal to scan.nextInt, next long rather. Okay, should we use long in C++ as well? Yes, you'll have to do that. 10 raised to 9, right? 10 raised to 9 I don't think will be sufficient in a 32-bit integer. Could be, actually, could just be. I'm missing my data parameters, but yeah, I think long is very much needed here. All right, so long answer is equal to s plus m modulo n minus 1, the whole thing modulo n, right? Whole thing modulo n. System.out.println should be the case, should work. Let's see what's the issues. lns. Let's see. That works. If I submit it, all right. Again, we missed the edge case also. If answer equal to 0, then answer is equal to n, right? This edge case we missed out. Can we take input as string? I mean, up to you if you feel like, but not really recommended. Okay. Where did we again make a mistake? If answer modulo n equal to 0, but that's what it is, right? It's already modulo n. Did we make a mistake somewhere? Answer equal to 0, then answer is equal to n modulo n minus 1. Huh. Is it a Python thing? 1 second. Python Java thing. A mistake somewhere? I less than, no, it's not that. 1L. Okay. Is it that one was not long? No, that was not the case. It's not that the one was long or not. You're saying I should do it like this, is it? Okay, interesting. Interesting. Yeah. The person suggested to me that should move the modulo outside. This is because Java plays weirdly with modulo, everybody. This is just because of Java playing weirdly with modulo. Java treats modulo numbers very different, negative modulo very different from a positive modulo. I've covered this earlier, but basically in Java, minus 13 modulo 14 is actually minus 13, whereas technically speaking, it should be 13 or something like that. So Java plays very differently with negative modulo. That's why the best way to do it is this, because you'll always get a positive number here. If you did modulo n here, there are chances that this thing might just be, it will not go negative. Yeah, but this might just turn out to be negative. S minus 1, this could just be negative because let's say this is 0. This m modulo n gives you 0 also because m modulo n is there. And this one becomes minus 1, let's just say. So, but here m will never be 0, right? M is not going to be 0. Hence, you don't get it. So if I do m modulo n, it's possible that you end up getting 0 plus 0 minus 1, and minus 1 modulo n will actually end up giving you minus 1 itself. That's the issue, right? That's why you in Java take the modulo outside only, avoid it to the extent you can, right? Basically, what I'm trying to say is in any step on the way, if your number is getting negative and you're taking modulo of that, you'll get undesired results. So actually, thanks guys for making me do this in Java so that you get to know this edge case also. Because I'll just show this to you also. System.out.println. Let's say minus 12 modulo 13. Right? Let me just show this to you, what it looks like. So in Java, minus 12 modulo 13 will actually be minus 12. Okay. Whereas if I did this in Python, that same thing, let me just do that here. Let's say print minus 12 modulo 13. Let's say if I did this, I actually get 1, right? Both are mathematically correct. But in this scenario, we need the positive number rather than the negative number. So avoid a scenario where a negative number is arising. This is a very good edge case. Thank you all. But yeah, this is the case where the negative number was arising. And because of that negative number, or not negative number, this was the case where m modulo n might become 0. And let's say s is also 0. So 0 plus 0 minus 1 will give us minus 1. Minus 1 modulo n will give you minus 1 only. It's not going to give you ideally what it should be giving you. It's going to give you minus 1 only. Whereas ideally it should have been giving you like n minus 1 most probably. But it's not. So that's the issue over there. Okay. Math.abs in the print statement. No, that would be incorrect because we're looking at modulo. We're looking at modulo over here. So that would be incorrect. For example, minus 12 modulo 13. If I take the modulo, if you do the absolute, it will become 12, but it should not be 12. It should have been 1. You understand? We saw in the Python, minus 12 modulo 13 should be 1. If I did the absolute value, it will give me 12, right? So that's where the issue is. Avoid negative numbers in a modulo with Java. Your life will be easier. Please avoid negative numbers in modulo with Java.